Hi everyone. So we'll start with our next topic, and our next topic is our zero order reaction. Next topic is our zero order reaction. Now just be careful, like whatever I'll be telling you guys now on, that will only include for reactions like these. A is giving me products. Only will be included for reactions like this. Now here, what will be the rate of reaction? The rate of reaction R, that is your ROR, will be K A raised to the power 0. Why 0? Because it's a zero order reaction. What does it actually mean? That your concentration has no effect on your rate of reaction. So in this case, your rate will be equal to your K. If we fully the graph topic, will do it later, but just understand through a graph. If I am taking rate with concentration, the rate will have no effect on change in concentration of your A. Rate will remain constant. There is no effect on your rate. Even if I take my rate with respect to time, what does it mean? My rate will definitely not change with time as well. That is my zero order reaction. Okay, so whatever kind of reactions we'll be going to study will come into an integrated rate law. Even for zero, first, second, third order reaction, for every order reaction we will be studying integrated rate law. So now we are going to study about integrated rate law for zero order reaction. We are going to study about integrated rate law. Now for the previous reaction, like A is giving you product, you can write the rate of reaction in two fashions, right? First fashion, what can you write it? R equals to K A raised to the power 0. Next reaction, what you can write? R minus of 1 by 1 dA by dt, right? These are the two fashions in which you can write the rate of the reaction. So we know both will be same, right? Just equate these both. Equating 1 equals to 2. What will you be getting? Minus of dA by dt equals to your Ka raised to the power 0. Now anything raised to the power 0 is 1, right? So minus of dA equals to your K dt. K dt. Now what do? You integrate on both the sides. Integrating on both the sides. Now I am just integrating on both the sides. Minus of dA. Now let us do one thing, like just transfer this minus to this side only. I'll tell you the reason why am I doing like this, so that it becomes more easy for calculation. Minus of K dt. Now how will I integrate? I'll integrate as if my K is constant, K will come outside, right? My A is coming from A0 to A and time is coming from 0 to T. Then what is going to happen? A0, A minus A0, right? A minus A0. Minus sign is coming outside here. So this will be A minus A0 will be equal to your minus of K T minus 0. Whatever is upwards, that is going to come first. So A minus A0 is equal to minus KT. I can write it like this as well. A is equal to A is equals to A0 minus KT. A is equals to A0 minus KT. Now what did I actually do? I just transferred this A0 to this side. So A0 minus KT. Now this particular thing is very important. A is equals to A0 minus KT. A is equals to your A naught minus KT, very important in zero order. This is your integrated rate law, where this A is your final concentration. This A is your final concentration. This A naught is your initial concentration. This is your initial concentration. K is your rate constant. K is your rate constant and T is your time. T is your time. Okay. Now, if I want to draw a graph of it, how will I draw it? Just write it in the form of y is equals to mx plus c. That's how you draw the graph in all the reactions, right? So, A is equal to, I am writing minus of KT plus A naught. Same thing only. Here, your A will be your y. Y is equals to mx plus c. I am writing it in the form of mx plus c. Y will be in my y-axis. This thing will be in my x-axis. This will be my y-intercept, and m thing will be your constant only, right? How do I draw a graph of it? On y-axis, what is present? The concentration of A will be present. On x-axis, what is present? Your time will be present. If I want to draw a graph of it, A naught is the intercept, right? So, it means the graph will look like something like this. Which one will be tan theta? I told you a trick. Take your left hand. Whatever side is facing the front side, that will be your theta, the positive theta. So, this is my theta. So, slope equals to tan theta, and this is theta is actually your minus k. So, your slope will be k. This is your slope. This is your slope. So, slope is minus k, which is your tan theta, and here intercept will be A naught. This is how A is equals to A naught minus KT. This is how you represent your zero order reaction. Okay. A is equals to A naught minus KT. Now, one more thing comes is your half-life of the reaction. What is half-life? By your name only, it is pretty much understandable that half-life of the reaction means whenever half-life of the reaction, it means whenever your concentration becomes half, your time becomes half, time in which it becomes 50%. What is half-life? Time in which, it means the time in which reaction completes your 50%. Time in which reaction completes your 50% at time is equal to T half. Time in which the reaction is completing your 50% study, that is your T will become your T half, and reaction is called as half-life of the reaction. How will you come into this conclusion? You know A equals to A naught minus KT. A naught minus KT. How much A should become? Final concentration should be exactly half, right? Half of the original concentration. So, this one will become A naught by 2 equals to your A naught minus KT half. If I want to solve it, like just reverse this thing, KT half equals to A naught minus A naught by 2, and then A naught by 2, like just take the denominator, 2 A naught minus A naught will become A naught, will be equal to KT half. So, T half here will be equal to your A naught by 2K. This is your half-life of the reaction. T half is equals to your A naught by 2K. So, don't memorize as such, because you will be doing a topic of nth order of reaction. That thing will particularly be more easy for you to memorize, but just see how the reactions are coming. For zero order reaction, your integrated rate law is A is equals to A naught minus KT. T half will be equal to your A naught by 2K. Original concentration upon 2 by rate constant. This is your half-life of the reaction. Similarly, there is one more thing called as lifetime of a reaction. Half-life of the reaction, it is called as lifetime of the reaction. What is lifetime? Where your T is equal to your T lifetime and your reaction is almost completing. So your A is actually becoming your 0. So what will happen here? A, you know the original reaction, A is equals to A naught minus KT. A is becoming 0. So A naught minus KT. So T lifetime, what will be T lifetime? KT lifetime will be equal to A naught. So T lifetime will be equal to, T lifetime will be equal to A naught by K. So these three things you have to remember. A is equals to A naught minus KT, T half is equals to A naught by 2K, T full will be equal to A naught by K. Obviously, like A naught plus 2K is half. So what will be full? A naught by 2K plus A naught by 2K, which will be equal to your A naught by K. Okay, now we'll do some questions based on your zero order reaction. Graphs, I'll be taking a separate topic for everything. I'll give you a short trick how to memorize all the graphs of all the kind of reactions. Now suppose if I'm telling you, just understand what I'm telling you. If your original concentration is 100 is your original concentration. What will happen after your half time? What will happen in your T half? See, A naught is my original concentration, which is my 100, right? What will be T half? It means half is complete, 50, right? So my time, actually my T half will be A naught by 2K. What will be T lifetime? A naught by 2K together. And T full lifetime will be A naught by K. Understood? So this is my 50% completion and this is my 100% completion. Equal time both are taking, right? Similarly, if I do one more question. You have 100, 90, 80, 70, 30, 20. Okay, so now I'm giving you the timeline. This is another question. Time is T. So what does this 100 to 90 means? It means your 90% is getting completed. 90% completion is happening. So the question is telling us, like a question has different parts. So the first part is telling you how much is time for 20 concentration. How much time is for 20 concentration, or you can tell 80% completion. See, first thing is you can directly calculate. You need 20 concentration, right? What does this 20 concentration means? Just remove this 90% completion. This will not be here. 20 concentration. What does 20 concentration means? It means 80% of the reaction is already completed. You have already moved to your 80% completion rate to reach your 20 concentration, right? So how much time in total you have taken? 1, 2, 3, 4, 5, 6, 7, 8. 8 T's, right? 8 T. Similarly, second question you answer. How much time for 40 concentration? How much time for 40 concentration? How much time will it be? 40. Where is 40? Just mark your 40. How many T's you got? 1, 2, 3, 4, 5, 6. 60, right? 40 concentration means how much completion rate? 60% completion, right? So 100 minus 60. 40 is left, right? So 60 is your answer. The third is, okay, little tricky. From 90 to 85, how much time it took you? 90 to 85. If 90 to 80 is taking me t, so half will be taking me t by 2. Easy, right? So what does it mean? In zero order reactions, unitary methods can also be used. You just need to calculate times. If from here to here, t time it's taken from here to here, how much time it will take. So technically you can use your formulas also. A is equals to A naught minus kt, or you can directly use your unitary method only in zero order reaction. We'll do more question based on this. Okay, the question tells you this is your reaction for A, directly giving you product. This is your zero order reaction they have mentioned. Okay, so now they are telling if time taken for 50% completion, if time taken for 50% completion is 2 minutes, how much time they are taking? 2 minutes, right? Find the time required. Find the time required for 75% completion. So let us do one thing. Let's first attempt it by using the formula. Then we'll use the unitary method. What is the formula telling? Time taken for 50% completion. See, we know our formula. A is equals to A naught minus kt is a formula, correct? Now, time is given, like your T1 is given to you as 2 minutes. 50% completion means original is 100, right? Let your A naught be 100. So, 50% completion means how much is left? 50. How much is the time? Everything is given in this equation, right? Second time, what they are telling? You just know here A naught is your 100. Time taken for 75% completion. 75% is already completed. How much is remaining then? 25, correct? You don't know time. You need to find the T2. So how will you find it? Just substitute all these values in the formula. First part, substitute all the first part things. So what is your A? A is your 50 equal to your 100 minus kt. And time is your 2 minutes, right? So this is your 2. We need to find k here. So what will you do? 2k equals to 100 minus 50, which is equal to your k is equal to your 50 divided by, 2 time equals to your 1 minute. 2 equals to your 50 by k. Let us assume this is 50 by k. This is your first equation. Same thing you do here. 25 equals to your 100 minus kt. We don't know what our k is as well as your t is. So now kt equal to 100 minus 25. What is 100 minus 25? 75. So your time here will be 75 divided by k. We got two equations. Now try to divide these two equations. Do 2 divided by 1. 2 is t by 2 equals to your 75 by k divided by 50 by k. K and k gets cancelled. T equals to 75 by 50 into 2. So how much it will be? 2 2s are 4, 2 5s are 10, 25 into 3. What is 25? 15, 2, 6, 75. So answer will be 3 minutes, right? So this is how we have done through formula. By formula, this is how you do it. Second thing is by unitary method. If I am trying to solve this particular question by unitary method, what are they telling? 150% completion is taking me 2 minutes, right? So means till 0 if I want, it will again take 2 minutes. What are they asking? Time required for 75%, just exactly in between. So 2 plus 1 minute. Like here it will be 1 minute for 75, and from 75 to 0 it will be another 1 minute. So the time required will be 3 minutes. Easy, right? More easier than your applying the formulas, but applying formulas you are like much safer. Okay, next question. Similar question, try to do it on your own. The question is telling you A is giving me product, and this is my zero order reaction. Now it's telling us it takes 2 minutes for your 50% completion. Find the time required. First do it by formula and then try it by unitary method. Find the time required for 33.33% completion. So we'll first use the formula. Assume your A is equal to your 100. Sorry, A not equals to your 100. In first case, what is happening? Your A is equal to your 50. 50% is completed and time is 2 minutes. In second case, what is happening? Your A is 33.33% completion. It means what are you going to do? 100 minus completion. The completion is 33.33%. So we'll do 100 minus 33.33, which is 66.67. And find the time required. We don't know the time. Exactly same things you have to do. You know the formula. A is equal to A naught minus KT. Let us like directly solve it from formula. A is equal to A naught minus A. Time equals to A naught minus A divided by K. Do both the cases, first and second. So what is the first thing telling us? Time equals to, time is already given, right? 2 minutes. So we'll directly substitute. 2 equals to 100 minus 50 by K. 2 equals to 50 by K. This is my equation number A. Not A. Let's take it as equation number 1. And here we don't know the time. And it will be 100 minus 66.67 divided by K. Time we don't know. 100 minus 66.67 is 33.33 divided by K. What do we do now? 2 divided by 1. (33.33) divided by K into your K divided by 50. So time equals to 33.33 divided by 50 into your 2 minutes. 2 2s are 4, 1, 5. So once you calculate, you will get the answer as 1.3 minutes. So the answer will be 1.3 minutes. Okay. Now how will you do it by unitary method? This was direct formula, right? How will you do it by unitary method? We are assuming 100 goes to 50, 50 goes to 0, right? This is like 50% completion. 2 minutes, so it's taking 2 minutes from here to here. Definitely it will take 2 minutes from here to here also. What are they telling? time required for 30%, 33.33% completion. So now what do we do? After 50, just divided 60, 70, 80, 90 and 0. 33.33% completion means 66.66 we want, right? 66.66. So 66.66 will come somewhere here only, right? So if this is 2 minutes, see 50% completion is taking place in 2 minutes, right? What interval will we do for 10 minutes? 2 divided by 50 into 10, that is 0.4 minutes. So every for 10 concentration change, you are getting 0.4. 0.4, 0.4, right? So now till 50 you already know that it is 66.6, it's taking your 2 minutes. Now this is asking for 50 to 70. So this thing will be 3 into 0.4. You understood why this has happened? From 100 we are going directly to 70 now. So 70 concentration I am talking about, not time. Not your completion. So 70 is the concentration. Till 70 concentration, how much is will be the time taken? Time taken will be 0.4. So 3 into 0.4. Now we need to reach till 66.66. So that thing will be 0.4 divided by 3, which will be equal to your 1.3. Better do it by your, not by unitary method, because it's little confusing. Try to do it by your formulas only. Okay, few more questions left. Okay, the question is telling us for a reaction, time required for a reaction, your time required for 20% completion. The time required for 20% completion is 40 minutes. And 40% completion is 80 minutes. 40% completion is 80 minutes. Now they have not told us the order, if you think here, right? So what are they telling us here? Find the order of reaction you have to find and the rate constant. So whenever questions like these comes, you need to follow a particular order. What do you need to do? Do hit and trial method. How do you do hit and trial method? If there is zero order kinetics, what will we do? Find two values of K. If the two values are same in zero order, like if you are applying this thing in zero order formula, if two values of K are same, it means or nearly same, then this will mean this is a zero order reaction. And if not same, we apply the same formula to first order. If K is same, then means it is a first order reaction. If not, we'll apply for second order, and this means it is a second order reaction. Okay, now for zero order reaction, we know the formula. A is equal to your A naught minus KT. What are they telling? 20% completion. 20% completion means, let us assume your A naught is 100, your A is your 80 then, and time is 40. Let us substitute this thing in your formulas and see if what is your K coming as. A is equal to your A naught minus K into T. Kt equals to 100 minus 80 is 20. K is equals to your 20 divided by 40, which is equal to your half or 0.5. Similarly, apply the same formula for your second things, which whatever is given. So A is your 40% completion means how much is left? 60. A naught is 100 minus K and time is 80. K will come out to be 40 divided by 80, which is half, which is 0.5. So both the ends case coming as same in this formula, in the zero order formula, right? So it means your your reaction is a zero order reaction, or your K value has also been defined 0.5. What will be the rate constant? Moles per liter time inverse or second inverse. Since this is given in minute, you can write it as minute inverse. Okay. Now we'll just do some examples of zero order reaction. We'll do some examples of zero order reaction. First reaction is your photochemical reaction. Like your H2 plus Cl2 is giving you H nu by 2HCl. Here your R will be equal to K, H2 raised to the power 0, Cl2 raised to the power 0. Actually here everything depends upon the intensity of light. How much intensity you are taking, in that only your rate of reaction will differ. So photochemical reaction is one of the example. The second example can be your enzyme. Any enzyme catalysis reaction can also be zero order. Any of the enzyme catalysis reaction can also be zero order. And third thing is dissociation of gases on solid surface. At high pressure, like for example, you have 2NH3 on high pressure is giving you N2 and 3H2. Here your R will be equal to KNH3 0. So these are some example of your zero order reaction. Next, a small topic is left of zero order reaction is special zero order kinetics. Special zero order kinetics. Let us do one thing, directly try to understand this concept from a question. Now the question is telling us 3A is giving me product, R equal to K, A raised to the power 0, and here your initial concentration of A is given to you as A naught. So what you have to do, find concentration of A after time t, and also you need to find t half. Now can I use this formula directly? A is equals to A naught minus KT. Just pause and think for a while. Can I use this formula directly? I cannot use it. Why? Because this formula and everything we have spoken till now was only applicable to reactions which were looking like this. I told you in the starting, A is giving you product. So only concept which will work here is we need to find our own formulas. R is equals to this. R is equals to minus of 1 by 3 dA by dt. What do? We equate these both, and what are we going to get? Minus 1 by 3 dA by dt will be equal to your Ka naught. Integrate both the ends. Take your 3 with a minus sign there only. Integrating dA by dt from your A naught to A will be equal to your 3k minus 3k. Integration of t will take place from 0 to t. We will get A minus A naught is equals to minus of 3kt. So now your formula comes out to be A is equal to A naught minus 3kt. Similar looking formula only, right? So when we compare these both formula, we come to a conclusion that K of reactant will be equal to K of reaction into the stoichiometric coefficient. Stoichiometric coefficient. K will be equal to K whatever was original into the stoichiometry. What is the stoichiometry at 3A? Okay. Now what will be the T half? We know T half was equal to your A naught by 2K. Here instead of your K is becoming your 3K here, right? So A naught 2 into 3K, which will be equal to A naught by 6K. Okay. And how much will be your half-life? A naught by 6K. Okay, two questions more will do based on the same concept. The question tells you 5 by 2A is giving me product. 5 by 2A is giving me product. Here my R equals to K A raised to the power 0. And my initial concentration of A is equal to your A naught. You need to find the concentration of A after time t and half-life. You directly know how do you find it. A is equal to your A is equals to your A naught minus KT. You know your KT has become 5 by 2. So A is equals to A naught minus 5 by 2 KT. Initial concentration of A is your A naught only. Initial concentration of A is your A naught. Yeah, that only we have done, right? And half-life, how do we find the half-life? We know T half is equals to A naught by 2K. So here your K is your 5 by 2. So T half will be equal to A naught by 2 into 5 by 2K. So your half-life will be A naught by 5K. Easy, right? Just multiply your stoichiometric coefficient with your K. Okay, next question. Last question for zero order reaction topic. The question is telling you A plus 2B is giving me product. A plus 2B is giving me product and rate equals to Ka naught and B naught. It means it's a zero order reaction, right? Initial concentration. I'm telling initial concentration of A is equals to A naught and B equals to B naught. So what do you need to do? Find concentration of A and B after time t, and you need to find your T half. Okay, same thing. You know A is equals to A naught minus KT. See, only thing is we just need to separate A and B reaction. So A is equal to your A naught minus KT. Now K doesn't have a substituent, like coefficient is 1 only. So we'll just put 1, and T half will be equal to your A naught by 2K. Simple, right? Similarly for B, B is equals to B naught minus KT. What is K here? 2K. 2KT. And what will be your T half? T half is equals to A naught upon 4K then. Sorry, B naught upon 4K. Why? Because K is your 2K. So I hope your zero order reaction is easy. Zero order reaction is nothing but your reactant is not dependent upon, reactant's concentration is not dependent and upon the concentration, and also your, then we did your integrated rate law. A is equals to A naught minus KT, and then we did T half. T half is equals to A naught by 2K. T lifetime will be E naught by K definitely, and then we did your special type of zero order reaction where your K was equal to your whatever K is there plus your stoichiometric coefficient. Okay, I hope everything is clear, and next time we will be doing your zero order reaction. Okay, so that's it for today. Thank you so much.